I think we are live, hopefully. I'll like refresh. Oh, it's hot. Let me take off my jacket real quick. Okay. Uh, so we're gonna be doing part 3 of the text editor today. Hopefully we get something actually working though. I slept and I just woke up and I have a cup of coffee, and so hopefully, you know, that sleep helped. Which I think it did. I think I have an idea on how to fix it because I was having nightmares about my bad code and what I was doing wrong. And I didn't sleep very good because of that, but I think now I could probably fix it though. So let me like put this somewhere there, and it'd be nice if someone like joined chat to help me to help me fix this because I might need some help. But alright, so let me get to sorry, I'm still waking up. Okay, so where were we? Let me just go into the folder. Oops, let me do that. Let me exit it. Where was the wait, okay, wait. What am I doing? I don't even know. So, episodes. Just do that. And then, editor. Okay, so we left off in code, I think. Oh, okay, yeah. Broken to do fix after sleep, yes. Okay, so I don't know what I was okay, so looking at this now, actually, I was just trying random stuff. It's what it looks like. Um, so basically, I'm trying to go through the rope and then draw everything, and this is not the right way to do it. A good way to do it would be recursion, but I really didn't want to do that. Like, I didn't want to do a recursive loop inside of my draw rope function. And then I realized that's kind of what the stack is like. That's why like on the wiki it mentions stack. That's pretty much to like simulate recursion, right? And that's why you do it because you're like it's kind of like simulating like a call stack, right? And so I didn't understand that, and so I was just trying random stuff that obviously didn't work. So, and also okay, so I created this list thing, and this list is nothing like a stack. I mean, you can use it like a stack, but it would be hard to. So I'm thinking instead of doing this, we're just gonna actually create, a normal stack like we should have from the beginning, um, just to make things less complicated. Because I don't, maybe we'll keep this, maybe we'll use it. I don't know, for something else. Uh, probably not. Yeah, I'll just keep it, and then I'll just create a new one called stack.h or something. Oops. Okay, so let's implement a stack real quick. So how a stack? Okay, let me type def struct stack or stack and stack, and then basically how stack work. What am I doing? How stack works? You'll keep track of the top of the stack, obviously. So I think we could just represent that as a number. I mean, I guess maybe this. Yeah, no, yeah, it'll be a number. And then this is basically going to be like a dynamic array, except you keep track of the top. I'm pretty sure. Just from like thinking about what a stack is. And so if you want to like pop, you get from the top of the stack or the top of the dynamic like array or whatever. So I think we also we should probably have a capacity, just like a dynamic array, and then we should have like the actual size. So this will be like how many elements are actually in the list. So length of list. This would be max length of list. Kinda, not really. I mean, we change it. Uh, update capacity. Oh, let me put this in like. Let me fix these comments. So that'll be the length of the list, and then this will be the capacity. So just reallocate as needed. Basically, is what I'm gonna put, and then I'll just here keep track of top. Right, and then we're gonna you know actually implement a stack, so we're gonna have like push pop, and I guess that would be it. We also probably want like a create stack function, and so let's do that actually. Create it's following like my naming convention. I think usually if I wasn't using Raylib, I'd probably just do like create stack like this, which I honestly think that looks a little bit better than this. Just like I don't know. Okay, so we should also set like a thing up here. So define stack capacity factor. I don't know. Capacity. I'll just go with stack cap to 4, 5. Maybe we should. Well, okay, so we're gonna be using this stack, which I forgot to add like the actual value of like that's in the stack, but basically we're gonna be using this stack to like for rendering our rope. So I think we should just like pre-allocate a good bit of like memory just by default, since we know it's gonna fill up probably. So it'd be cool. Oh, maybe we should have it so. I'm thinking like. Oh, well, you know what? It doesn't really matter. Let's do like 5, right? And then let's just have it so we can set the capacity when we create the stack. So then we could probably just get a rough idea of like how many leaf nodes there are going to be. Just because it's a binary. Okay, so it's a binary tree. I wonder if there's a way to, or I wonder if there's like a good way, because like for our ropes like we have our root, like our rope node, whatever, it's a pointer, and then we have left and right. Couldn't we just like, well, yeah, we have the weight, so I think like the weight will be like, I think our weight's like 6 or 5 or something. So I think since we have the weight, and this is a binary like tree, we kind of know how many nodes we're gonna have, right? Or we should be able to predict how many nodes we have. And so I think, yeah, so we should be able to like just allocate as much nodes as we need, right? I think that makes sense. I don't know. Oh yeah, create stack. What is it gonna take? Maybe like the initial size or capacity, we'll call it. Alright, so then we also want to destroy it, so destroy stack. So stack, stack. Alright, and then we also want to store the value of what our stack's going to hold. It's a value, which in our case we want to pass in ropes. So we should probably call this like a rope stack or something. Which, do we want to do that? I wish I could make this more like dynamic, like make it be anything. I wonder how I would do that. I could technically just throw in like a void like pointer, or I could just cast this into a void pointer, and then like, yeah, and then like when I'm using the stack, I can have it set this like, yeah, I could just convert it or whatever. so we're live, right? And my mic is working, and everything's good. I think no one's in chat yet, which, from what I have learned, is live streaming with like 50 subscribers. You get like nobody in chat, so hopefully one day that changes. Cause I really want like it'd be nice to have other eyes on my code, so like when I make an error, I don't like just like forget. Like I mean, sometimes I'll put something down and then I'll know it's wrong, but I just don't see it because I'm not focused on it. So it'd be nice to have like eyes watching. You know, I think that make this. I think it would make the streams a little bit shorter probably. So okay. Oh, so we're and we gotta import it. Do I really need? I could just hardcode the like cat and the like. I don't really need that. Yeah, I'll just leave it. Include rope.h. Let me put that up here actually. Right. So this is gonna be a rope stack, but we're just calling it stack. Because it should be the only stack we need, like, throughout the program. I mean, what if we do need a stack eventually? Maybe we should just call this... I don't know how people do... Like... Would you just create your own, like, a custom stack for each thing? I wonder what's a good way of doing this? I think for now, just keep it like this. And if I need to update it, I can. It shouldn't be that hard of a refactor. I just want to get this, like, because currently I don't think anything prints. So let me, that looks right. So right now, like, we're rendering our code, we're rendering the editor thing, but text isn't rendering. So that's why we're building a stack now to get it rendering. What do I want? Oh, push and pop, right? Stack. Or what? What am I doing? Why do I do that? I always do that. I like copy the thing that I see like right here or something. See, like I'm still doing it. Okay, so yeah, push to stack, and then we want to take in the stack, and then the element that we want to put in it, which is going to be a rope. So yeah, and then we also want to pop from the stack, and then we take in the stack. Oh, and this will actually, like return a value from the top of the stack. So like that, and that should be all our all the functions we need. Pretty sure. You know what? I just thought about it. We don't really need size, do we? Because top will always be kind of like the size of the list. Yeah, okay, so we don't need this. I mean, I don't know if we don't even need to check the length at all, really. So, I mean, this is never going to be seen. So it doesn't really matter. But here, let's do this. Did we create a stack.c? No. Okay, so let's do that. And some people might be wondering why I'm coding like right when I woke up. So I don't know. Create stack. Okay, so stack. Just called stack, and then we're gonna allocate some memory. Right. Oh wait, what am I doing? Yeah. I feel like I'm forgetting something or doing something weird. I don't know. I just feel like there's a bug around the corner or something. Let me put that here. So we need a centered lib.h. Okay, so we get the size of stack, right? So we allocate a stack. The top of the stack should be just 0, and then stack dot what is it? Where's my autocomplete at? Just wondering. So maybe it's because of that. What is it? What? I don't know what I clicked. Oh, okay, we got our autocomplete back. Okay, so we had top, or we already did that. Capacity equals capacity. Alright, and oh, we didn't even put like, okay, wait, let me go back. We're doing something wrong. We don't want just one rope, we want a list of ropes, so something like that. Which, is that good now? I don't think I have to change anything. Yeah, I think we're good. And then we're gonna basically just we're gonna allocate that to the capacity. So rope equals this will be rope pointer, I don't know, size of rope, yep, times our capacity. Alright, I am pretty sure this is right. Let me just check the YouTube thing real quick to see if, no, still 0. Which ooh, I kinda wanna show off, I think I already showed it off. Did I show it off in this? I don't know. I wanna show off how many views I got on the first text editor video. The second live stream, or the second part 2 of that, yeah, no, pretty much no views so far because I just uploaded it, but hopefully it goes up. Let me see. Okay, so oops, check it out. We got 45 likes. Think about that, and also 1,359 views. It's pretty crazy. Like, just thinking about, like, if I was watching this video, I don't know if I would click like, because I rarely like videos, which I guess maybe I should like videos more to support like creators and whatnot, but I don't know. But I rarely do that, and then to get 45, I mean 45 out of 1,000 I guess isn't that much, but still like good bit. 45 people like went out of their way to like it, even though I mean it takes like 2 seconds. But yeah, you know what I mean. So yeah, I think that's weird. But because I didn't even finish the text editor in that video, and this one right here has 37 views, and I legit created a tokenizer in Python, so I thought that was a good video idea, but maybe it wasn't, or maybe it's the title or something. Maybe I should shorten it, get rid of the lo-fi beats thing. Let's edit that. Let's get rid of this lo-fi beats. Maybe we rename it to like creating a programming language in Python, and this would be like, I don't know, episode 1 or part 1, I don't know, part 1 like that. Should I do that? Should I do like a dash or something? I feel like I shouldn't put the part 1. I'll put like part 1 in the description. ChatGPT generated this, by the way. Yeah. So let me just put her. I don't know. Actually, just let me just keep it like that. So, oh, maybe like that. Like what I'm doing with the. Or this one's just gonna be part 1. Okay, I think maybe that'll get it more views. Let's see. Obviously we won't see now. We'll see in like, you know, later. But okay, so yeah, let me get back into it. What were we doing? Okay, so top 0, capacity 0, right? I think that's basically it, right? And then let's also just write the destroy. I like to write the destroy function right after I write the, create function, just because it's like, just do it in that order. I don't know. You don't have to do that. But, it's basically, what are we, yeah, we're just gonna free the rope. We're just gonna free this pretty much, and then the stack. So you free this, and then you free the stack. Yeah, pretty easy actually. Make sure you do it in the right order. Otherwise you'll probably segfault, because if you did that, this would be null, and if you try to free null, you just get like a segfault immediately. I don't know if that's always the case, but I think it is probably, or should be. Right. Okay, so we're gonna push an item to the stack. So basically, we're gonna increment the top, right? And then we're going to, well, actually, we're gonna stack, group, and then stack top. And this is going to equal that item, probably, right? But we should also check some stuff before we do that. So, what do we want to check? We want to check if, probably stack capacity, or stack top is, okay, how about if it's greater or equal than the capacity? So if equal, yeah, I think that makes sense. Greater or equal to the capacity, we want to grow the list pretty much. So we'll do stack rope equals, pretty much do same thing, kinda what we did with allocating it, but we're gonna use real, yeah. Gonna use this, and basically give it the, pointer, and then the new size. So we could just do a size of rope times, should we just like, how do we want to double, how do we want to, or we should just add, we should just add in like, or we could just set it to size of, so times, stack top, or what are we doing here? This wouldn't make sense. Well, yeah, no, it does. It does. It does make sense. Okay. So here we set it to capacity plus whatever our factor is for which I think we delete stack cap. So I think we'll just add 8 or something. Will be good enough. And then you gotta make sure if you do that. So once we resize, we gotta update the capacity. If you don't, you're gonna run into some problems. So the capacity should equal, maybe I should have done it like here. So then I could have done like plus 8 like that, right? And then I could just put in the stack capacity. So pretty simple. Let's see. So yeah. So if we're pushing an item in the stack, we gotta check that the stack is the stack top. Well, if the stack top is greater or equal to the capacity, we resize the rope, and then we update the capacity. So pretty much we just grow the stack, and then we're setting the top to the item that we give it, right? That makes sense, I think. And then we increment top, right? Hopefully I did this right. I don't know. We'll find out. Okay. And then we might write like a print stack function just to test it. Okay, so popping the stack, you basically just, so what would you do here? Well, you want to get the, Do we want to do this? Maybe this? Because you don't want the exact top, because I think the top of the stack, like, top will be like the absolute, and or it'd be like, I think it'd be like bigger than the rope size, I think. Right? I don't know. We'll find out. So basically, this is how you would get the item on the top of the stack. So, item, which stack's it's not gonna handle the ropes at all. It's not gonna handle that data structure. So we don't have to do any freeing or anything, because we'll free it later. We're doing this basically just so we can, instead of recursively, printing out or drawing out each character, we can do it in like a while loop instead, so we don't have to have like a helper function. Yeah, okay, so let's see here. Okay, so we have an item, and then so we get the item, we also decrement the stack at the same time, and we should also should we like resize? Maybe? I don't know if we should resize. Let me just return this actually for now, and then, because if we're adding something, it'll just be kind of like, the capacity will just be bigger. Maybe if the, okay, so, because we could resize the stack. Hold on, let me take a sip of coffee. Okay, so we could resize the stack. When we pop a certain amount, maybe. Because it doesn't hurt to like not like resize it at all, because we're gonna free it anyway, like after we're done with it, and we're gonna like, so it's not gonna be long lived, so I don't think it really matters if we, but I kind of want to, yeah, I think we won't reallocate. Let me write a to do resize if stack capacity okay, yeah, well, we want to check the top, so the top is less than, probably want to resize it if it's less than the capacity plus 8, which 8 is going to be our just our growth factor, I guess. That should really, yeah, let me just define that actually. Define, I'll just go cat factor. And then let's just set that to 8 for now. Really, I don't think, we don't really need to do any of this, because we're gonna know the size of the capacity, and so we're never really gonna like resize the stack really, unless we need to do that for some reason. But right now I can't really think of a reason, but we're gonna do it anyway, just because maybe people will learn something from this, I don't know. So what was I doing? Oh yeah, cat factor here, and then I'm gonna write this to do, resize stack rope if stack top is less than the capacity minus the cat factor, I guess. So basically just resize if we don't like need all that space, pretty much. Maybe there's a better way, but I don't know. So this should be it actually. So Yeah, I think that should be it. Yeah, let's create a print function too. Let's call it like print stack group, and then we're gonna do a, I don't know, or wait, what are we doing here? No, not that. Print stack, and then we're just gonna take in a stack, and then, what's going on here? Okay, so then basically, let's see. We have a stack, and then we're gonna do like what? Oh, we should also have. You know what? It'd be good to have if empty. So like void is empty like that or something. That'd be good to have stack, and then basically we're just gonna return stack top equals 0. Whoops. Which we don't have booleans here, so I guess we can include it. Oops. Okay, so I think that's, yeah, basically how we check if it's empty. So, I mean, top would be like 1 if it wasn't, which I feel like this might be wrong. I feel like maybe we want to, okay, so we're popping the stack. I think we probably want to decrement it afterwards. Is that right? We'll find out. It'll break if it doesn't work. So, oops. Oop. Where did my mouse go? Oh, it's gone. I'm still streaming, right? Yeah. Is my stuff working? Oh, I should have checked if the mic was working. Yeah. Okay, so pretty much okay, so we have our stack, so we pretty much want to just check if it's empty. And then while it's not empty, we want to just empty the stack. Yeah, just pretty much. This is how, not empty, right? We just give it our stack. And then, yeah, while it's not empty, we're just gonna get the item. Oops. Item equals a stack, or pop stack, and then we'll give it our stack, right? Then I guess we can print out the rope or something, or we could just print out like we can print out the top. Well, do I have to include that probably? Well, it's gonna do like items, like a string, but that might be buggy, so let me actually just print out the top of the stack. So this would be integer, and then we gotta include that. What was I doing? I don't know. Zoning out. I think that's basically it. Yeah, it's not much. Pretty simple. See, like, and I was doing like really complicated stuff to kind of emulate a stack on a linked list, and it was just really bad code. So I think, yeah, let's just go into main. Here we just have our window, and then our UI element code, which I should have just called it like text edit or something instead of code. I think code might just be bad too. Oh, we still have the return, so we're good. So stack, we'll just call it stack, right? Whoops, we want it to be a pointer, which we're gonna free it. Create stack, and then let's say like the initial capacity is like, we'll 5 or 3, let's see, yeah, 3. And then we can include it, or like this. Right, so we have a stack. I'm also going to destroy the stack, and then before we destroy it, we're going to actually print the stack, which is not available to us yet because we didn't add it in the header. Where is it? Boop. Oh, that's not the header. Here. So, like, what was it? Just print stack. So this will also empty the stack though, so, which maybe we want a function to empty the stack, which, I mean, I don't think it would matter. We don't really need that, honestly, but, so I think, right, yeah, I think that's it. So it's tested for our stack print, so first we have to add stuff to the stack probably. So push stack. So we're also testing that out. Just do like create rope. We can just leave it empty, which, let me just do that, 0. What happens if I put 0 in there? I've never tested that. Should have better testing. I feel like it'll break if I do that, but I actually don't know. But it would be good to know if it breaks. So let me just test one item now, and then, oh, we didn't add our stack. So stack.c, let me zoom. Just add our stack, and then we print out 0, so that's the top of the stack. And then if we have like, what is this? 1, 2, 3, 4, 5, 6. Let's keep it at like 3 so we can tell if the reallocation works properly. And which also I want to go back into stack, and then I want to add a new line. Okay, so it should work, right? Yeah, so we got 5, 4, 3, 2, 1, and 0. Basically how you'd expect a stack to pop the items. Okay, so now that we have a stack, let's try to use it for our text editor. Just so we can print out the rope. And yeah, so we'll do that here. Well, after I fix main, I gotta put everything back to normal. Let me just undo everything. Yep. Okay, so I think that's good. And then, yeah, let's go back into code. And then hopefully we can get something drawing. So stack.h, put it up here just because we don't really need the list anymore. Our useless list. Is this for fun? Yes. How's it going, Stanley? Okay, so what are we doing? Boop boop. Basically going to create a stack here, create stack, and then I do want to figure out how we get the size. So since it's a binary tree, we'll do like 2 times. Do we store it? We don't store the original text. Which, should we store the original text? Probably not. You know, it doesn't matter. We could just, it doesn't have to be, let's just allocate like, I don't know, like 8 items for now. It'll reallocate itself when we need it. Okay, so basically we're going to do while is not empty, right, for the stack. We are going to, oh, actually we also have to push something. We gotta push the root node to the stack. So push stack, and then our code root, or rope. Push our rope to the stack, right? And then we want to handle if it's a leaf node or not. So, am I doing this wrong? Is empty stack. Oh, is it? Oh. I don't think I added it. Void is, let me do stack empty, because I think is empty might exist somewhere else. So I'll go here and change this. Right. Then we also have to change that. And then, did I break something? Is stack empty? Is stack empty? Wait, what's our problem? Is stack empty, right? Void. Oh. Mistyped. It's a boolean, which is that just gonna work? I feel like it should work now. Stack. Yeah, okay. We can just put all this in there. Okay, so that should be working now. Let's go back to where we're the code. So now it's is stack empty, right? So if stack's empty, we want to check the current node. Okay, so we got to pop the current node or the current item in the stack, which will give us a rope or the current rope that we're at. So should I just call it current? Or I'll just call it item. I don't think matters. Pop stack, and then give it the stack. Oops. Alright. Okay, so then we check if this is the leaf node, and how do we do that? We check if the string is empty, or check if check if it's not empty. So like, I'm gonna put a comment. Check leaf node, or handle leaf node. Handle, and then so yeah, item string. Okay, so it's a leaf node if it's not null, pretty much, I think, right? And then okay, so if it is, we just want to draw it. So draw text, item string. This should be pretty easy. And then our X position, which we want kind of relative, right? So yeah, we'll have it I'll just save it here like this, which is gonna be the X for our editor, or yeah, so it'll be relative to the code editor's position. So we have that, and then Y, which is for now we're not going to have any text wrapping, I don't think, which we have to figure out eventually. It shouldn't be too hard though. We'll just put Y, and then also do this here. So Y, and why we're putting it like that is because we're going to increment X after I put in a font size of some sort. Which, do I have a font size? Yeah, okay, font size 20. That's going to be our default font size of this. Not going to be able to change it really. We could probably fix that. We could make it dynamic. Which, should we do that now? I just want to see if it works. So, let me just not do that now. And then we get code, and then the foreground color. So it should print out like white text, I think. And then what we want to do here is increment X by we're going to use measure text, item, string, and then the font size. So basically that should handle that correctly, I think. Yeah, so that just draws that, I think. Okay, so then we gotta I think we gotta handle the right side first. And then, so basically how we handle that is, if item dot right does not equal null, we're basically going to push it to the stack. So we get their stack and then item right. And this is kind of going to simulate like recursion pretty much, because while stack isn't empty, we just run this loop, and then so we're kind of just feeding the loop right now. Oops. What's up with that? Okay. Push stack, item, left. Right? Do we need to handle anything else? I think that's about it. And then that might actually just be it. I think that could be it. I don't think we're missing anything, but let's find out. So let's clear it, and then oh, let me just show off that we have the rope, and it's just hard-coded text. So it should print out "What's up, dude?" And it's okay. What's the problem here? So let's see. So we get the item out the stack. This stack's empty. Maybe this is wrong or something. Oh, we're also not freeing it, so it's also free the stack, or destroy stack, right? Yeah. So I don't think that's the error, but that's, yeah, so that's not the error. So we're obviously doing something wrong. Okay, so what are we gonna do here? So we get the current item on the stack, in which maybe this is just wrong. Called the, what is up with that? This should be in there. Yeah, okay, I don't know. So pot stack. Okay, so maybe it was the other way around, because I was thinking it was this way, but I wasn't sure. But wait, we did test it, didn't we? Oh, okay, so it was the other way. Yeah. Okay, so we got the text. Okay, so we have a rope data structure, and we have it printing correctly, so that's pretty cool. Let's see here. What do we want to do? Well, that's pretty nifty. Now we basically, okay, I gotta stop saying basically, because I'm gonna keep saying that a lot. Yeah, so this is our rope data structure, and this is pretty much how a rope works, just to recap. So we have a rope, and then on the left side, we're gonna have the minimum length of, oops, it should be 5. So 5, which is the text including the terminator, null terminator. I gotta drink something. My throat's dying. Okay, so basically, I just said I would stop saying basically. Okay, so we have the string, and then we have the weight, which is just the length of the string. But it could be, so the weight could be less than our defined weight here. So it should be less than or equal to this. So pretty much each chunk should hold like 5 characters. Or in this case, this would be like this, actually. Or here, let me just change this to 6. Because just for like demonstration. So yeah, if our weight is 6, then we'll show up 6 characters. So this is only 5 characters, but you gotta remember there's the null terminator. which maybe I'll add that in the thing, so it's just like, yeah. So, and then we have the remainder, which is 4. Oops. So this is how our, hold on, I had a, sorry, I had a, I had a drink, I had to drink more coffee, actually. Oh, my voice, probably gonna lose it. Yeah, so this is the representation. On the left side, the left side's always gonna be at least the weight or less, and if it's less than the weight, then we shouldn't have a left side or the right side. So say this was say our whole text was like just hello, then we'd only have a, oops, let's not break it. Then we would only have yeah, the left side, and the right side wouldn't exist. So yeah, so basically just splits. Oh, I should probably look at the. Let me go to it. So right here, this is how we create it. And okay, so we pretty much, this is how it balances. This is how we balance it. We pretty much take the string, split it in half, and then handle each half separately. And then, but when we're, okay, so when we're dealing with the most, like the leftmost side, we only out like the, so this is what's making the leftmost side at least the, you know, size of weight, is because we're doing this. We're doing, if a length is less than or equal to weight, then we create the left node pretty much, or the leaf node, and yeah, I don't know how to explain this good. I sort of explained it in the last video, sort of, kind of as I was doing it. I don't know if it made sense to people, because I'm just really bad at explaining things. But once you visualize it, it's kind of easy to understand. Which I can't help people visualize this, honestly. But yeah, let me try at least. Okay, so you have your, oops, hello. Okay, so this is the text we're putting in. So like that. So basically, we take this text, we split it in half or whatever, or we split it. Yeah, we split it in half, and let me think here. We split it in half, then we feed it into here, and then it kind of just balances itself. I don't know. It's not a good explanation, but hopefully you guys can understand from like this, maybe, how a rope works. Or you could just look at the Wikipedia. The Wikipedia is pretty easy to understand. I only looked at the Wikipedia for a few seconds, so I'm not like an expert on ropes. But yeah, so all my knowledge of a rope just came from the Wikipedia image, pretty much. And that's, yeah. What is this? Text edit? I don't even think we use this anymore. Yeah, this is just... Does this exist? Yeah. Okay, so let's go back to main, and then let's run it again. Make sure I didn't accidentally break something. See, we got the text here, and so it's good. It's good. We got text. So now we have to make it. I do want to make it so we can edit the text. So we'll have to have like some sort of cursor, and then we have to be. We'll have to be able to move the cursor. And also I gotta like update our rope so it can append, because right now yeah, we just okay, so right now we just create a rope and we destroy a rope and we don't handle it, and then we also have print rope, which It's AI generated, so I didn't have to do that. But we don't use this anywhere. I don't know if it's like I think the code's probably fine, but I just have it say AI generated just in case. Um, so if it does break, then I'll just assume it's like bad code or something. Okay, so we want to do append rope or append text, or the way I name this is kind of bad because I don't want to put like append rope. I'll just do it because we're not appending a rope, we're appending text. Well, yeah, so I named everything kind of weird, I guess. I don't know. Yeah, so how do we want to do this? We could use the stack again, probably. And so no, we can't. No, we couldn't. What do I call it? Stack. Oh my. Oh yeah. Okay, so we need do 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 do. I don't know actually. Maybe okay, so maybe I won't work. Maybe I won't deal with the pending right now, and then I'll just like set up the cursor real quick so we have that at least. Yeah, so let me just set up the cursor just so we have something that's like interactive. So in code.h, this is how we represent our code editor. Just store the rope, which I don't know if any of this is right. Never built the text editor before, so I'm not an expert. So we'll see. But here I want to pretty much have, I want to save the cursor position, which is going to be an int. Well, it should be like an unsized int actually, because I never want it to be less than 0, because you can't have a negative cursor position really. How do we, include, I think, where is size t at? I don't really remember. Is it in here? Probably not. I don't know. We'll see. So yeah, cursor x, and then size t, cursor y. Or should we have cursor? We should just have, I think the cursor should only just store one position, right? Because we're not dealing with like, we're dealing with the text as it's like one big long stream. So yeah, we just need to store this pretty much. And is that working? Size t is imported. What's the type alias for size t? What is this? Huh. I don't know. I don't understand that. Alright, so we got the cursor, and I just want to be able to, oh, also I want to store the font size. Just so when we're measuring the text, we just can get it from the code, and so it's not, and so it's like dynamic instead of, you know, hard coded like it is right now. So let me just delete that so it'll error out wherever we have it. And oh, also gotta firstly like code font size equals, oops, it's just gonna be the same thing, but yeah. Cursor's gonna just start at 0, at the 0 position, and then we'll move our cursor around, and then the cursor will be the size of the, like a single character font size, I think. So yeah, probably just measure it like a space. Maybe we should measure it here. Maybe, yeah, maybe we should do that. Should we do that? Yeah, cursor size. Just so we don't have to recalculate it every time. which I don't really care if I do that. I'm not going for performance. I'm just going to, I just want an editor. Um, so yeah, so we'll do measure text, and then like it's just a single space, and then the font size, which is code that font or code font size, and so there. Let me put this afterwards then. And then it's mad at us, so let's fix it. Cursor size. Just so we don't have to calculate the size of the cursor every time. Great. Yeah. Now thinking about it, the rope, it's either going to be the size of, or each leaf node is going to be the size of, either weight or less. So I mean, if we set we could use this cursor size to like set up the size of, yeah, let me try something real quick. So this should work now. Oh, and then we gotta fix this. So I'm thinking instead of measuring the text every time, we could just do the code cursor size times the weight. I think that makes sense. I'll find out. And then code font size. So now here we're not like measuring it out every time, so let's just see if that works actually. So what happened here? Oh, so it should be like probably +1, so like weight +1 I think. Oh, maybe? I don't know. Let's find out. +1. Okay, so we ran into some problem here. Maybe I was wrong with that idea. Oh, because because it's like variable size. Yeah. So how about cursor size times, we could do like the length of the text actually, like string length. But then we're gonna be doing that I don't know. Let's just do that, I guess. We're gonna run into some bugs later probably. Right, okay. So let's do +1 probably, or something like that. I don't know. +1. Nah, I don't know. Maybe the size of each character isn't the same. So maybe we do have to measure the text each time. Which is fine, I guess. I don't know how this function works, so I don't know if it's like, like expensive. Let's just assume it's fine. So yeah, let's just do this. Let's just do this. Size. Okay. So it should be back to normal. And then, oh, I do want to render we want to render the cursor, right? And how are we gonna do that? Should we draw the rope first? Yeah, I guess we want to draw the cursor under the text. So we should probably do it here. And then it's just gonna be a little rectangle, I think. And then the position will be what? Okay, for now it's just gonna be the cursor, or where the cursor is, and then I should set the cursor to the size of the text or something, right? Just so it's at the end. Nah, that's fine. I can move it. If I could just move it to the end. Maybe we'll have it like automatically go to the end if we need to. Okay, so code, just like the normal y-axis. we'll offset this by like some bit like later after we figure out how to do new lines. Okay, and then the width and height, which I don't know what the height's gonna be, but the width is definitely gonna be the cursor size. And then let's just say the height's gonna be the font size, I guess. Right, and then I think let's just do, what do we want here? Maybe blue. Let's just do blue just to test it. So we should see a cursor at the beginning of the text, right? And it's only half of the. Okay, maybe this font has like variable length for each character or something, and that could be the problem because it is off. Which is how do we fix this? or maybe it's just the spaces, right? So this is kind of bad, but we should probably handle this better. Maybe we should do it like dynamically. Maybe we should. I really don't want to. Let me change it to X and see what happens. So instead of measuring like the size of a space, we'll measure the size of a character, but then it'll be off for the spaces. So yeah, so now it's like the size of, oh no it's not, it's still off. Yeah, so I think this font has variable length characters, which is not good, because now we have to deal with that. I could use a different font that just doesn't have, you know, just to make it easier, but I don't know. Let's see, we could get like the leftmost, or how do we, I don't know. We could create a function inside the rope that gets the current character at the cursor, which is probably how we should do it, and then we can get the size from that. But then I have to write that, and I kind of just wanted to be able to move this around easily. Yeah, let's maybe write that. Alright, so for a rope, we want to, maybe we want to return, yeah, I guess we want to return the text, or we just want to return a single character, right? Or do we? How do we want to do this? Because we're going to be doing this a lot. So it's going to be kind of slow if we just, I don't know. Yeah, let's just do this for now. And say, cursor, rope, or cursor, at, rope. Well, I don't want it. Okay, I don't know. I kind of want the rope part to be first. Like rope cursor at, or something like that. But that doesn't follow the same thing I'm doing here, so I don't know. Let's just do it's fine. We'll just do cursor cursor at, and then we'll take in the rope, and then just like where we're at, which is gonna be size T. Oops, which I should just do size T for everything. For length, because length can never be negative either, I don't think. Or what if it does? I don't know. It shouldn't. It should never be negative. But I'll just fix that later. I don't know. Okay, so cursor at, and then, you know, the position. And then all I want to do is, let's just use it int. That's fine. Because maybe we want to use like a negative number to get the, like, to get the opposite, so to get the inside of the rope or something. I don't know. Just handle a negative differently. Kind of just making this up as I go. Not gonna be great. So let me copy this, because I just want to return the character just so I can just get the size of the character and so I can print it properly. Yeah. But how do I do this actually? How do you go from well, I guess you would, well, we might use the stack to, no, well, I guess since it's, oh, well, I mean, we use a binary tree for a reason, so I guess it would be a binary search, right? Kinda, maybe? Right, okay, so I mean here, the root node should always be the size of the leftmost node for some reason. So does that really help? We don't really store like what we need. Or do we? We kind of do. So like the root would be size of like 6 or whatever. I don't know. So this would, yeah, so the root would be like size 6, just from like this or whatever. And this one, what's the weight for this? The weight would just be the size of like whatever's in there, or the leaf node. So this would also be like size 6. And this would also be size 6. And then this would be, well, this would be 6. I picked a bad example for this. And then this one would be length 4. So, I mean, I can... I mean, to get the size, like, to get the cursor position, I could just, like, okay, so if the cursor is greater than, whatever's on the left, okay, yeah, so if the cursor is greater than the root node's, left position, like, if it's greater than that, then we just immediately go to the right side. And then, basically do that recursively, I think, right? Because, if it's bigger than this, we just go to the right, and then we get, the rope that we need. And then if it's smaller than the root, or yeah, if it's smaller than the root, we just go to the left. Oh, okay, so I think we're good. Hopefully we can just implement this real quick and not like struggle on it for hours. I probably just jinxed myself, but whatever, I don't care. I don't really need this actually. I might just delete it. Or maybe it's good to have for debugging, actually. So let me just keep it. But I don't want it touching my code, so just do that. Alright, so what do we do here actually? Okay, what were we doing? We're doing cursor at rope, which we're just gonna okay, so maybe I just want to like do current, kind of traverse it like it's a linked list or something. Maybe. And then while current does not equal null. Oops, what is up with my text editor? I'm just gonna return like something for now. Or no, I won't, because it'll... Can I just won't write it. I don't know. Just so I have this error here, just in case I forget. Or at least this warning. It's not really an error. Okay, so we get our current rope, which is just rope. And then, well, we wanted to check the left side and... Okay, wait. Well, no, actually, we want to... Okay, wait, this should be easy, because I just explained how it worked. If, if cursor, or no, wait, current, weight is, less than the position, or less than or equal to, Yeah, less 2 or equal to, or less, or yeah, less than and equal to. Then we're gonna, okay, so then we're gonna choose, or basically just gonna do this. Current equals, current left. Right? And then, otherwise, we are going to do current equals current right. So this should get us, I think that's actually it, which is pretty cool actually. Maybe we should do some error detection or something, but I don't know. So, and this looks kind of weird like this. I do that. Okay, that looks a little bit better. Yeah, I think that that could actually be it. Right. Oh, we also want to store probably the length. Or no, we got the length of the rope because it'll be in here. As long as it doesn't equal null, we should be good. Oh, maybe we should break if we hit a leaf node or something. Because I think, yeah, because I don't want this to equal null ever. So maybe I'll just do true. Well, true. And then, what am I doing wrong? Did you mean what? No. I'm just, okay. So, well, true. Yeah, that makes sense. And then, okay, so what we're gonna do is break out if it's, if a string does not equal null. Let me do that. Break out if leaf node, right? Because if the string doesn't equal null, that means it's not an edge node, because an edge node, yeah, okay, so yeah, that should be it. Yeah, I think it's good. I'm not even gonna think about it. Let's just pretend it works. Rope, which we want to get the string, but we want to get the position, which is going to be the current rope, or yeah, current weight. Ooh. Yeah, minus the position, right? Okay, maybe I gotta think about this line right here. I think it was gonna be something like that. Cause let's think about it. So say our weight's like I don't know, like 5. Or yeah, let's just say our weight's 5, and then let's maybe we're looking for the fourth. Yeah, let's say the length of our string is the length of our string is like 5, or let's say 6, I guess, because this would be 6 because you have the null termination or whatever. Right. So the length of it is 6, and we want to get the 5th position. So then we'll get the length of that. So okay, so we want to get the 5th position. 5th position. Let's just write it like this. And then, so then we're doing the weight, which the weight is 6 minus, okay, so then we're doing weight minus the position. Alright. Ooh, actually, I think we could just do, yeah, wait a minute. Okay. Oh, we should, that's gonna be so wrong. I think we have to probably keep track of the sum. Let's see. Position. Because, we need to offset it. So let's start at 0. Oh, which way we have position, so we need to call it something else. Let's just call it sum. Or, yeah. Yeah, I don't know. So let me leave that. And then we're just, yeah, so each time we're just going to pretty much just add the weight. So we could do that at the end. So sum, add the weight. And then this, add the current weight. So that should be fine. Should be. But let's see. Okay, and then we want to do the weight. Well, how does this work? Maybe we do the... Okay. Do we actually need this? The size of the string is... I don't know if it's important or not. Let's think. Because I just want to get the position that's going to be in here. So I think we might just like do... I feel like it's going to be something like a sum, like in the mod, the position or something. So, okay, let's say, say we're looking for maybe number like, 20, 23. We're gonna, and then let's say our total sum right now is like, 18. Right? Let's say something like that. I don't know. Okay, so then we do maybe, yeah, total, okay. Okay. I'm struggling here. Gotta do math. Okay, so we're checking the current position, 23, and then the sum at the end of this is gonna be like 18 or something, or some random number. It's gonna be the sum of all the elements, right? So that'll get us our length. So yeah, that gets us our position, at least. And so this will be like the actual, this will be the actual position in the code that we would get, or the sum at least would be. And then we want to check like, yeah, like, okay, let me think about this. If we do mod position, which is, would be that. I feel like I'm doing something super wrong, but it's fine, I don't care. 18, 18, mod 23. We just get 18. Oh yeah, obviously. Wait a minute. Let's do this. So I think, yeah, I think that would give us our relative position that we need here. So I think we want to do, are we doing this right? So like, something like that. And then, the position. Or not the, oh wait. The sum. Because, say we're looking for maybe like, wait, is this dumb? How dumb is this? Okay, so say we're looking, we want element 6 of like this here. Maybe our weight's like, you know, let's say 3, or so it'd be like that. So what am I doing? So we just have pairs of 2 pretty much, till we get to here. So we want, okay, so we want character 6, so 1, 2, 3, 4, 5, 6. Oh, we would get, okay, we gotta ignore these. Okay, wait, so, oof. No, I think we're good, I think it would be ignored by default anyway. Okay, so 1, 2, 3, 4, 5, we don't even have 6. My bad, wait a minute. Let's get position number 3. Okay, so we want position number 3, so 1, 2, we sum it, so currently we have the sum of 2, and then we have 1, 2, so then the sum's 4, but we want position 3, and so we're doing, we want position 3, so we're doing 4, oh wait, it should be the other way, right? 3 to get us 1, which is the position in the text that we want, But I don't think that applies to... Oh, okay, wait a minute. Should we just try random stuff and see if it works? Maybe. Hmm. Oh, wait, I'm dumb. Okay. I think we just want to do, we just want to do position minus sum. Right? Cause say we give like 23 or something, and our sum's like 18. Then, or let me do like easier math. So say we put in 20, and our sum was like 15. Then we want the character at the 5th position. Okay. Okay. I don't know what I was doing there. Let's hope this is right, and should we just like pretend it's right? Let's not test it at all and just assume it works. That'll be fun. Okay, so okay, we want to go back to code, right? But instead of doing this here, we're gonna go, do we have an update function somewhere? Yeah. Do something, please. Yeah, okay. Then we'll just constantly check the cursor position, right? By doing cursor at rope, we take in code rope, and then we take in the cursor position. Cursor size, or cursor, yeah. And then we don't really, I'll just do that. Okay, well, this just gets the current character, which we need to put it into, okay, we can do this. Yeah, or a const character, or whatever, 2, and then we'll do character, 0 equals that, then we'll do null termination, like this. Can we not do that? Should we do that? What's going on here? Did I type something wrong? I don't know, whatever. We'll just, this should count as a string, sorta. Can assign, oh, it's const, my bad. Oops. Alright, okay. Let's just check if, so, I mean, if it did work, the cursor should be the size of the first letter now. Or we'll segfault or something, I don't know. You never know. Right? Yeah, we did. Okay, so should we try to debug this? We're definitely accessing something we don't have. So let's see. Let's go back to rope. Let's see what we're doing wrong. This week. Oh, okay, wait. We should do that before we do this. Right, because this could end up turning into null. Okay, we still got a problem here though. What if we're indexing wrong or something? Let me try like -1 or something just in case it's like, nah, that wasn't it. Okay, so to debug this, I guess let's try it, okay, string doesn't equal null, break, then pretty much, well, wait a minute. Oh, okay, because we're accessing string, the string might not exist. So, right? No, because we should, Mm, Oh, maybe we should okay, so maybe we shouldn't break out, or maybe we should break out at the end after we change these, because uh, current string might not exist, right? No, wait, what am I doing actually? Go back to that. So this might not exist, so I guess we can also just do a check if current is null. If current equals null, this also just break. Let's see if that fixes something. No, it's still sig fault. What is causing the sig fault? It's definitely because we're accessing something that doesn't exist. So let's see here. Okay, so okay, so we know for a fact that current exists like here. So let's sum up the weight from here. And then that still didn't work. So current. Okay, so then we set current, and then we. Ooh, I actually don't know. Oh, maybe. Well, let's check this. Let's see if this is it. So let's just return a like normal. Like just return a random character or something. Okay, it's definitely the way. Okay, so it has to be this. Which maybe I'll print it out so I can figure out what the thing is. So we're gonna do integer position minus sum. Wait a minute. We're looking for position 0, but it's gonna be at least the size of sum. Uh-oh, I don't know. Oh, let me just, so wait, if we made it, say we made it 5, maybe we should, start out some, or maybe, oof, what do we do here? Because I just realized, yeah, like, position is gonna be 0, and then the sum is gonna be, whatever the thing at 0 is, or it's gonna be, well, it's gonna be at least 5, right? Let's print out sum, and then let's also print out position. Let's see if let's just return like some random thing. This is how you debug, guys. Let's see. So 0, 18. Ooh, why do I get 18? Shouldn't it be... Wait. Am I doing something wrong? Maybe we should only add the weight if it's a leaf node? Does that make sense? Maybe. So 4, 0. Oh, 0, 4. Right. So wait, the sum is 4? Why is the sum 4? I think the weight is, what's the size of our weight? Our weight's like 6, isn't it? So why is it 4? Oh, no, I don't know. This is odd. I'm obviously doing something wrong. Well, that's probably right. Let's go back to, where were we? Rope. Okay, let's think about this again. For some reason, sum ended up being 4, which I don't think that's the length of this text. so maybe it's like weight plus 1 or something. No, I don't know. That should not happen. That shouldn't. Some shouldn't be 4. Oh, maybe I didn't go through everything. Like it. Maybe. Okay, so maybe it should stay out. Hmm. Oh, this is a tough one. An hour and 35 minutes. Oh no. It's kind of a long time. I was hoping to have like actual like a text editor kind of sort of thing going on by now. Alright, so we check if the current node is null, then we break. If this is null, we also break. And then let's just, okay, let me add some over here. Let's see if we get a different result. So 14. Well, the sum, oh, well, I mean, maybe we only added on the left. Maybe? Does that make sense? So 0, 0. I mean, we get 0 at least. So, wait, what if the cursor's something else though? Because I think it does make sense to only increase it if we hit like, like, I don't know. We should only, yeah, increase it when we select the left node. Maybe. It's a tough one. Let's see. Where do we do this? So let's change the position to the cursor, and so this should be 1. So I should just print out 1, 1, 0. Right. So and then let's go over the weight. So 6 or something. Or I don't know if that's necessarily over. Yeah. Okay, so we go over it, and then we're returning. I think we're doing something right, actually. Okay, so our cursor we set to 6, but it gives us 5 as the sum. So then we do the 6. Yeah, we do the cursor position. So the position minus the sum here, and then that should get us the character we want. Also, what the heck? I think so. I think we got it. So yeah. So what did I say? Yeah, yeah. I think that should be good. Sick fault. What? It just worked a second ago, right? Or what was maybe wait. It was okay. 6, 5. 6, 5. Position minus sum. String. Oh, maybe this might be minus 1. Well, what if they're both 0 though? I don't know. See, wait. What's going on here though? Shouldn't this work? Position minus sum. Maybe the rope, maybe we have the wrong rope or something. Maybe we shouldn't break out here. Maybe let's break out in here. So current No, I mean, maybe that's just fine, actually. So... thinking... Let me try this. Just, okay, we got -4 for some reason at some point. Okay, wait, that gave us 10. Because we don't break out, probably. No, maybe we... How about, current dot string, or, yeah. Let's have it so it breaks out here. So string does not equal null. Let's just break. And that means we got the string we wanted, I think. Okay, okay. So, I mean, I guess it's the exact same thing, I'm pretty sure. So... should we add this? So, okay, so we're asking for 6. The sum ends up being 5, which means something's off. Right, because if we want position 6, well, no, okay, well, we got the 1, which is, well, we didn't technically go over the weight. I don't know, this is tough. Let's see what happens if we put this out here. Should change a good bit, I think. Now it's the same. Okay, so that's cool. We just leave that there, I guess. Right, so, I mean... So what is, oh, let me also print out the rope string, so we can just see what's going on here, before it segfaults. What? Okay, maybe I'll put that back, because I don't know what just happened there. So... Oh, wait. Oh. Problem is, rope string doesn't exist. So, we should probably have a temp. Rope, temp equals... Well, do we need a temp? We can just... Maybe we should break up, we should check beforehand, actually. Maybe that fixes it. No? Okay, wait a minute. What's going on here? We got 6, okay, so 19. Which is interesting, I don't know. Let's, We got 5, 1 again. Okay, so... the string still equals null at some point. Oh, wait. Well, we're kind of ignoring the right side too, so... So maybe it's because we're ignoring the right side. So maybe we should also break out at the right. Okay, wait. So, I mean, if we're gonna write it like that, then we could just do, boop. Which, let me see. Is that gonna cause an error? Because it might just, because content might be, I don't know. We're kind of just going back to what we had. Because, it might be null. Let's just find out. So yeah, Oh wait, it's still printed up to here, so this didn't mess up anything at least. So we want to set it. Maybe we can just store the temp over here or up here. Or how about we do if maybe something like that. But maybe also the right. I'm just trying random stuff right now. Okay. Okay, there's definitely something wrong with my logic, and I think I'm too like hyper focused on this to like think about it properly. So maybe I should maybe I don't know. I was gonna say like take a little break or something. I don't know. Okay, so doing something super wrong. Cause the save fault's at this. So rope. Okay. Let's just store the previous. Let's just do this for now, cause it should work. Previous, null. And then we're gonna pretty much just make a previous equal current. Do the same thing here. Well, actually, we could just, since we're doing it like that, we could just do that. Right? No, can't do that. We'd have to put it here. Let me just, yeah, I don't know, trying to format. So maybe like that. Let's see if it seg faults again. Yeah. Oh, well, we're still checking, let me check previous instead. No, still, previous is, well, we're not handling leaf nodes right anymore, I don't think. So current string does not equal null, and then we want to set previous to equal this leaf node, right? So only set previous if we hit a leaf node, I think. No, still not. Oh, what is going on here? What am I doing? Well, maybe, okay, let's see if, maybe the stuff isn't flushing. So, no, it's definitely this. I'll get rid of that probably. If current equals null, break, right? If, okay, so everything down here is assumed current, exists. So current string does not equal null, that means it's a leaf node. So then we set previous to that leaf node. Which we should probably actually do. Oh, that's tough. Maybe we should do that here like this. And then, ooh. Now we can put this at the bottom, I guess. If current equals node, then, or null, then maybe we set current equal previous or something. Am I overcomplicating this? Okay, let's, oh, and then we don't have access to that anymore, so, current. Okay, so I think we just went into an endless while loop. So it's not breaking out properly. So, left, right. Oh, okay. Oh, I meant to break. Also break. Alright. Ooh, that's my... Okay. Oh, no, we're not doing a new line. Let me do a new line. So I think we are getting the... I think we are getting it. Sorta. Why is it getting this side? I don't know. So, oh, we're getting... This is odd. Alright. Okay, so our position, we're asking for 6. We get the sum of 10 for some odd reason. Well, I guess that maybe makes sense. Maybe we should do it the other way around. Okay, so maybe do some minus position. That's just so then that gives us 4, so 0, 1, 2, 3, 4. I think that's like way ahead. I think we're getting the wrong node. Oh man, this is tough. We're definitely getting the wrong node here. So maybe oh, what is this? I need to break that actually. Okay, so we get 6, 4. Yeah, why was I doing this? Current equals previous. Oh yeah. So this is tough. I'm doing this super duper wrong. What are we at? Like almost 2 hours now. Alright. Let's see. Let me also zoom out. Or no, let me just put that away. Okay, so maybe we should just rebuild this function. Maybe. I don't know. But we don't even care. We don't even care about where the actual position is, or what the total position is. Do we? We just want to get the character we want. Oh yeah, we do. So wait, we should be checking the sum. Right? Or no? No, I think we're good on this actually. Let me... so if we hit a leaf node, let's just break out. Let's get rid of the sum stuff. Right, and so if the current weight is under the position, we set the current to left. And then if, otherwise we set it to right. And then we don't need this anymore. Let's just see what we get. gonna be null, right? Now we get 6 and then, or we're just giving the position. So, we get the same text, which I don't think that's the right text. I don't think that's the text we should be getting. Right, so we set to left. Maybe I'm thinking about this wrong. Wait, current weight. Wait a minute. I don't think we're supposed to be doing this. I think we're supposed to be... Okay, so this should be less than the sum. Okay. I think we got it. So let me set sum to 0. And then, as long as this position is less than sum, right? No. Ooh. Actually... I want to check if, this is tough. Oops. So, I think basically we're just gonna do sum plus, current weight. I thought I had it. I think I'm getting closer though. I think, let's just see what this prints. Okay, so we get that, which is still wrong, I think. So let's maybe only increment up here like this, and also we can get rid of this previous node. It's old. Okay, so we get that. No, that's not quite it. So, sum, maybe minus the weight. Let's just see what this gets us. Like, okay, so yeah, that seems more right. But why do we do the minus weight thing? I'm thinking it's because we're adding it wrong or something. Or how about we just, Oh, well I guess we just, okay, so 0, and I don't know if we're gonna add the current weight. Maybe we'll just add weight. Right, and then, maybe that makes it so we don't need this. Right, okay, so 0, 1, 2, 3, 4, 5, 6. So 6 would be this space right here. So this would be the 6th position. So I think we got it. Okay, wait, let's also print sum. Make sure that's like right. And then sum. It's be exciting if we get it. Okay, so the sum's 18. Definitely a lot over. But I think it's just because, yeah, maybe we should do it afterwards. Do the same stuff? Yeah, we get the same text, but now it's 12. Okay, so position minus sum. Well, that would just give us 6. So maybe we don't need, actually, maybe we don't need, well yeah, we do need to do that, but I don't think we're doing it right. I think we also gotta do like minus weight. I think it'd be like minus weight like that. And that would get us the position we want. Maybe? No, well because, let's see, I'll just give a 0 or negative 12, what? Oh. Nope, gotta think about it. Okay, so we're adding in this weight. Oh, maybe, yeah, let's go back to doing this. So we only add the weight if it's, we are on the left side. Right? So sum. Okay, wait. We're asking for 6. And we got what? So, yeah, 1, 2, 3, 4, 5, 6. Wait. Well, it starts at 0. So 0, 1, 2, 3, 4, 5, 6. Let's see. Maybe do like -1. Because this is including the null terminator. So wait, let's just go back to doing, this. Wait. Okay, so we get sup and then we get 6 and 9. Ooh. That's tough. So yeah, let me cancel this. So we get 6 as the position, which is, yeah, what we're giving it. And then we get sum, which is 9. So maybe it's sum minus weight. Or weight minus sum. Well, sum is bigger than, okay, wait a minute. Get 9, why do we get 9? Oof. Is that what we want? How do we get the position from that? Because we get the right text at least. And then what was it? I think the space was number 6. Yeah. How about if we subtract subtract the current weight from that. I don't know. Oh, okay, yeah. Get 6 and 5, so minus that would get us 1, which would be the position of this. So hopefully this is not just a coincidence. Oh, and we got a chat from it's a Russian name, I'm not gonna be able to pronounce that. So yeah, hi. Oh man. So let's try this. I think, yeah, that should be good. Okay, wait a minute, wait. What's going on here? I thought it worked. Let's just return that for now. So yeah, our position and our sum, and then oh my, wait, was that the error the whole time? What if I had it at some point? I was doing a rope string. It should have been current. Oh, Okay, so I think we're good. Let's just assume it works. Got it. Okay, wait a minute. That's what? Why is it that's okay? Uh, huh. We are getting the correct character, right? Oh, maybe we're not. I don't know. Well, we still got to get. We gotta get the width of like all the characters before it, don't we? That's terrible. Since it's variable width, okay. So how do we do this exactly? Because I think the size was right. It's just the offset was wrong. Uh, so I guess we can kind of figure that. Okay, we can get that from how we draw it. We can get the size of until a certain point, I think. And that would be like the offset, I think. So let's try some stuff. I'm in the wrong thing. Or no, I'm not. So I'm pretty sure, yeah. So if I set it, let me set the cursor to 0. So set at 0, it should take up the width of, okay, uh-oh. Oh man, it doesn't work. Why is this, if we, okay, maybe it has to be like 1. Let's do 1, cursor 1. No, okay, so we get 0, or we get 1 and 5. Oh man, I thought we were done with that. Oh. Okay, I gotta go back to it. Alright, so we're doing something wrong. So wait, do we even get the right string? No. Oh, maybe if, maybe we should return something early if it's, less than the weight. So if, yeah, so position is less than the weight. Let's just, do something else, I guess. Is that the right way to do it? I guess, I don't know. So, maybe just add this in here, actually. Let's just have it so it breaks. See what that does. Huh. Maybe we can try that up here. I don't know. Well, we still need to. Okay, wait a minute. Position is less than sum. Right. Ooh, this is tough. I don't know. Okay, so wait, it should be fine though. Because okay, so we're asking for position 0, which the sum starts at 0. So then we add that which probably not what we want to do. Yeah, this is a problem. So yeah, yikes. It's not great. Okay, so our position is 1, and then we get 5 printed for the sum. Let's maybe, what if we subtract, oops. Honestly, I have no idea. So this is tough. We got so far. Now what to do? Maybe there's a better way to do this that I'm just not doing. So then again, I'm just gonna, okay, so I'm gonna just return 0 or something. Oh, we never segfaulted, so I mean that's something. But yeah. This is tough. We could set I mean in our draw, okay, so we could set we can do this a different way. I think if we go into our code.c, we could just when we're, you know, rendering the list, we could get the offset from there, and then we would also be able to get the character from that. So we could just do that for now instead of doing this. So maybe for now, okay, for now, okay, we just want, but we kind of need this later, or something like this later. I don't know. We're going to, yeah, we're just gonna get the offset from the draw loop thing. So so I guess I don't want to do that though. I kind of wanted to do it I don't know. We should do some game dev or something. So yeah, let me just get the offset, or cursor offset. I'll just have it called offset equals 0. And then basically we're going to, well, it's just going to equal, well, as long as, oof, do I have like a counter? Character length. So yeah, well, we're also going to do this character length plus string length of item string. That's going to be our well, yeah, it's just going to be that. Okay. Or actually, well, we want our, oh, it's just going to be the same thing we're doing here, I think. It's just going to be our offset. So, oh, okay, so I guess we don't really need, well, we need to stop it at some point. So, cause we gotta see how far we got, pretty much. So yeah, I think, yeah, we do need to do this, I think. And then once, the character length is less than our code and cursor. So yeah, something like this. Yeah. This is where we'll just like stop adding, or as long as okay, wait. If yeah. As long as cursor is greater than the character length, just keep on like you know, like appending or we should wait. Do that here. So just do this every time, or yeah, just do this until character length reaches up to that certain point that we're at, pretty much. And then, oops, I guess that would be it. We can print it at the end just to see what we get. Print F I, and then just print our character length. I also want to do same thing here, or oh wait, well that wouldn't be character. Okay, wait. We want to do that, but then we also want to do cursor offset equals X. Right. So let's print those together. Print F. The offset. Let's call this one offset. It's definitely not the right way to go about things, but we're gonna do it anyway. And so character offset, or what is it? Cursor offset. Right, and then we have the character length. Great, now print. Okay, let's see if that offset is right. So this would be in pixels, so it might be right. And then 5. What did we ask for? What's our cursor at? Cursor's at 1. So why is our character length at 5? That can't be right. Maybe we let's do it before this. Right, so our offset's gonna be 0. Oof, wait a minute. Okay, wait. Why is our character length of this? This is only less than or equal to cursor, so maybe it's just less than cursor. What? Yeah. I mean, okay, wait a minute, actually. So it should be equal to cursor, right? Because we want to offset from cursor. Well, you know what? I think the offset is right, and it's kind of all that matters. Or is it? I don't know. Let's see here. Yeah, okay, so character length is going to be 1, and then our offset's 0, which we picked cursor 1, so our offset should not be 0. Probably. Well, we can put this over here again. I think that's the problem. So we're looking for an offset of like something, and then character length of 1. Okay, still no offset. Character offset equals X. Or what? Oh, wait a minute. Yeah, wait, we're measuring the whole text. Offset character length equals 1. Oh, okay, well this doesn't help. I'm like confusing the heck out of myself. Okay, so let me just put this back to 0 and see what we get. So character length 5, which nope. Okay, character length is 5 still. because we're adding the length of it. Oh, which we shouldn't do. So we just add one. So character length is 1, and then offset is 0, which that's not true. It should not be 0. I don't know. Oof. This is gonna be so complicated actually. I think I'm gonna stop doing this. Just thought about it a little bit more. Oops. Yeah, let's not do that. So I guess that means we gotta go back to doing what we were doing before. Sucks. Alright, so we get rope. And then what were we printing here? So let's see what we had printing. Okay, so our position that we asked for position 1, and then for some reason the sum is 5, and then it gives us that. So we want to do, because maybe yeah, I don't know actually. Okay, I just spent like 22 minutes doing also nothing. Okay, I'm gonna have to pee. Maybe we'll ask AI. Maybe it knows. I kind of don't want to ask AI, but might have to for the video, just so it's like, you know, I'm gonna use ChatGPT, I think. What am I doing wrong? You know what? What am I even doing actually? I don't know. Let's see. Comparison tree suggests solutions for the tree, accumulating the weight until position is found. Yes. That's what I was trying to do. Sum. Oh. Let's try this out, see if it works. We had something similar kinda here, except we had it somewhere else. But maybe the logic for this makes more sense. Left. Oh. That's interesting actually. Cheating. Maybe people will skip through and not notice. I'm not like trying to hide it, but I don't know. I should feel like a little ashamed. So return the, okay. Then, yeah, okay. Let's just see what this returns. We didn't print anything. I wanted to print the, can I print it? Right, I don't know. I guess I can just, I can't really print it here, can I? let's just, well, to test it, we can just check if we're getting the character we asked for. I guess that would be a good way of checking. Let's go here. And then, where are we? Are we supposed to be here? Okay, so yeah, we're in code. And then, where do we set the character? An update? Oh, yeah. Okay, so let's just print out. Yeah. Oh, string, new line. New line. And we'll just, yeah, print out the character. And then hopefully we get, like, what we wanted. So, H. Yeah, that is the character at that position. So we're doing good. Try 0, see if that works. Okay, so, I mean, I don't think my logic was, like, so far off, so I want to give me, like, a half, that's like a half win, but really the point goes to AI at that point. Yeah, so 6 is probably it, right? 1, 2, wait, is that right? Wait a minute. Wait, it starts at 0, right? 0, 1, 2, 3, 4, 5, 6. No. Okay, so AI lost. uh, maybe it's assumed something about my, okay, so, yeah, maybe it's, like, thinks my rope is designed differently. So I think I could probably fix it. Because, okay, we're adding the weight here. Weight. Ooh, I don't know. Yeah, okay, so if this is greater than the position, then we go to the left. That seems wrong. The left, wait, the left. That doesn't seem right, does it? I thought it should be the other way. Oh, just get 0 at that point. Oh, and also, what the heck? I didn't even remove that. So I think, let's try this. String, and then, you know, position, minus some. So we get H. What? Okay, so maybe this was right. Well, it's just gonna give some, yeah. Dude, this is tough. Maybe there, okay. I don't know. Okay, so I think this is right. And I don't think I'm supposed to be summing here. I feel like I'm supposed to be summing here. But then we get nothing. So maybe not. Maybe we just keep it as sum. No? Why do we add the left node on the right? Wait a minute. What? That is so odd. Let me just undo everything AI did. I'm kind of like, maybe, what did they do here? Current, not null. Well, I don't need to do that, I don't think. So they added the weight, of the left node on the right side. What if I just do that? Here, let me see this. Okay, so what am I printing exactly? Okay, so position 0, we get 6 for some reason. And then what? Oh no, wait. I think we're printing this. Okay, so this is the position. We're asking for position 6. And then the sum is -5? Why is the sum -5? What did I do wrong? Wait, how did it become negative? This is odd, isn't it? Or am I doing something off here? Oh wait, no, okay, this 0 is from something else, right? 0, okay, let's just assume this is, are we asking for position 6? Yeah. So, oops, I just deleted that buffer. I didn't mean to do that. So then we're adding, oh, we subtract, okay, we're subtracting the weight there, which we probably shouldn't do. But do we want to do it anyway? I don't know. Let's just do this. So, right. We ask for position 6, it gives us 0, which is not right. So, maybe we should like subtract like the weight or something instead of like, well, why was this why was this like, okay, I don't know, it's just only added if it's hits the end. Right, so we get 6 and then 5. So then, oh, we're not even getting the right string even either. Oh wait. Oh no. I'm gonna like cut out half of this video probably. Yeah, okay, so I think that's gonna be it for the video, and I'm gonna like cut out like all the trial and error and kind of leave in the rope stuff maybe. I don't know. Okay, that's gonna be it.